to start with. All right. Where's my pens, guys? Okay, so you guys, if you graph the tangent function into your calculator, tangent of x, and we have this window right here. Does everybody have this window? Okay. So we're just going to look at it really quickly right here. This is what it looks like. Notice that this is called, a tangent function is an increasing function. In fact, I would write all these answers down in your notes. Okay, put y equals tangent of x, and you're going to write, this is y equals, all right, so here we go. Y equals tangent of x is an increasing function. That means as you go left to right, it always goes up. Notice that it continues over and over again to do the same pattern. So the very first question is, after you sketch it on your bell work, it was, what is the period? What is the period of this thing? How long, how far to how far does it take to complete one cycle? Pi. Why? Why do you say that, Cassidy? From where to where? So from this dotted line to that dotted line, where does this dotted line occur at? What's this mark? Negative pi halves. And what's this one? Pi halves. So from negative pi halves to positive pi halves is one full pi, right? Okay, so one full pi and one cycle takes place. This is different from the sine and cosine function. On the sine and cosine function, we learned that the period was 2 pi. So on the tangent function, the period is pi, just one of those cycles. In fact, it has these dotted lines I'm putting represent the asymptotes on the tangent function. Okay, remember an asymptote is that imaginary barrier or that imaginary line that the graph will never cross through. Okay, so that's where the asymptotes occur. So question number 1, what is the period? What is it? Pi. Question number 2, what is the domain? Who can say what the domain is? Domain is how far it stretches left and right. So which numbers can it not be left and right? It cannot be pi halves. Why not? Yeah, the graph will never cross that. So at pi halves, if you said, okay, x is pi halves, the y value would be undefined. So at that point right here, the domain is all real numbers except for pi halves. What else? Right here where this asymptote occurs. What's that number? No. Huh?
2 pi.
No, 2 pi is right out here. We set our window to 2 pi. Huh? Yeah, it's 3 pi halves. So you have pi halves. This is 3 pi halves. What's this one over here? Negative pi halves. What's the one on the far left? Okay, that's a negative 3 pi halves. And so the domain happens at everywhere except for pi halves, 3 pi halves. Where would be the next place out here? 5 pi halves, 7 pi halves, 9 pi halves. How could we describe those numbers? That's exactly right. Odd pi halves. Okay, so everybody for the domain is all real numbers except for odd pi halves. All real numbers except for odd pi halves. Okay, question number 3. What is the range of this function? How far up and down does it go? It goes more than 8. Infinity, yeah. Goes up forever and down forever. So how do we explain that? What's the range? All real numbers. Okay. Next question. What are the x-intercepts? In other words, where does it cross the x-axis? Name a few points. Where does it cross the x-axis? 0. Where else? Yeah, pi. Because it's pi fourths, pi halves, 3/4 pi, right? Pi right here is where it's crossing. Okay, where else does it cross? 2 pi. Where else? Negative pi. Where else? Negative 2 pi. Where else? 3 pi. Negative 3 pi. Okay. How could we explain that? How could we describe it? All multiples of pi. Okay? So the x-intercepts occur at multiples of pi. Okay, next question. Where does the y-intercept occur? 0. Okay, next question. Where do the asymptotes occur? All the pi halves, all the odd multiples of pi halves. Because it's just odd multiples of pi halves. Even multiples of pi halves are pi and 2 pi and 3 pi. Because like 2 pi over 2 is just pi. 4 pi over 2 is 2 pi. 6 pi over 2 is 3 pi, right? But the odd multiples of pi halves, like pi halves, 3 pi halves, 5 pi halves, 7 pi halves, are where the asymptotes occur. That's also where it's undefined on the domain. Okay, so the domain doesn't exist there. Okay, you should have that in your notes and on your bell work. Turn in your bell work quickly. Okay, here you go. So we already did tangent function. So now I want everybody to put the cotangent function in your calculator. Okay, right here we're talking about the cotangent function. So what does the period, so answer the following questions with your face partner. So it says graph the cotangent of x into your calculator. So how do you put the cotangent of x into your calculator? Yep, 1 over the tangent, remember. 1 divided by the tangent of x. Remember that tangent and cotangent are reciprocal functions of one another, and so you can just go 1 over the tangent to graph the cotangent. And so there is a cotangent function. How is this function different from the tangent function we just looked at? What do you mean it's opposite, Joe? Yeah, so Joe, notice it flips. In other words, it's a decreasing function. You know how the tangent function was increasing? This is a decreasing. Everybody write this down in your notes. The cotangent function is a decreasing function. It's going down left to right. Okay, it's a decreasing function. Okay, what else is different than the tangent on this one? Yeah, that's exactly right. So you can see, because our asymptotes are still up there, right? So I need to erase these asymptotes. Okay, and we need to draw on our new asymptotes. There's one right here along the y-axis. There's one right here at pi. There's one at 2 pi. There's one at negative pi. And there's one right here at negative 2 pi. Okay, and yeah, and there's this one right here. Okay, so we're ready to answer the questions here. First question: what is the period of the cotangent function? What is the period? Pi. Once again, so like from 0 to pi, 1 cycle takes place, right? So pi. Okay, next question. Number 2. What is the domain of the cotangent function in the given window? What is this? What's the domain? Huh? All reals except for multiples of pi, right? Because every pi, what happens at every pi? An asymptote. So write down all real numbers except for multiples of pi. Okay, third question. What is the range? Huh? All real numbers. It goes up forever and down forever. Good. Okay, next question. Where are the x-intercepts located? At pi halves. Where else? Negative pi halves. Where else? Huh? 3 pi halves. Negative 3 pi halves. 5 pi halves. 7 pi halves. 9 pi halves. What do we call that again? Odd multiples of pi halves. So the x-intercepts are at odd multiples of pi halves. So notice how the asymptotes and the x-intercepts interchange between the tangent and the cotangent. Okay. All right. What is the y-intercept? There is none. Yep, there is none. Okay, good. Doesn't ever cross the y-axis. Okay, and where are the vertical asymptotes located? We already answered this question, really, when we answered the domain. Where are the asymptotes? Multiples of pi. Okay, any questions on that? Okay, we're going to go on to the next one. This time, put the cosecant function in your calculator. So how do you put the cosecant function into your calculator? Okay, 1 divided by, did I say the cosecant? Yeah. Then it's sine, right? 1 divided by the sine. A little bit different, isn't it? Yeah. Different than the tangent and cotangent. Okay. All right, what do you guys think the period of this one is? Why do you say pi?
Because it starts at 0, doesn't go by 0, and it goes 4 over, and it doesn't touch there either. It does touch all people.
Okay, so 0 to pi completes one of these U shapes, is what you're saying.
Yeah.
But look at this U shape down here. Isn't that a different?
No.
Because it's going.
It starts at pi.
But it goes down, right, instead of up. So can we say that these are part of the same cycle or different cycles?
Different because they don't touch.
Okay. Well, what I mean is they're all part of the same cycle. In other words, it takes both of these parts to complete a cycle.
Okay.
So if it takes both these parts to complete a cycle, what's the period? 2 pi. Yeah, it goes all the way to 2 pi from 0 to 2 pi to complete that, right?
Yeah.
Does that make sense? Okay, so you guys, once again, the cosecant is 2 pi, just like the sine and cosine, whereas the tangent and cotangent were periods of pi, right? Okay, next question. Number 2, what is the domain? What do you think? What's the domain of this function? Are there asymptotes, first of all? Yeah, there's asymptotes along the y-axis, along at negative pi, along negative 2 pi, along pi, and along 2 pi. Okay? So the asymptotes, the very last question is, where are the asymptotes? They are where? They're at multiples of pi. So did we answer the second question, what is the domain? So what's the domain? Yeah, all reals except for multiples of pi. Okay? Next question is, what is the range? Nope. Say that again? 1 and negative 1? 1 to negative 1? 1 to negative 1, he's saying. Yeah, it's all reals except for the numbers between what? Negative 1 and 1. Because if you'll notice, this one comes down and it touches at 1. And these bottom ones come up and touch at negative 1. But there's no part of the graph between negative 1 and 1. There's kind of an empty space. Huh? They actually touch 1 and negative 1. So it doesn't include them. So the way you would write that, the way you would write that, the range is y is greater than negative 1 but less than positive 1. So y is a number between negative 1 and 1. Oh, wait. No, I'm sorry. All reals except for those, right? I should put except. Except numbers between negative 1 and 1. Right? That's the range. Okay, what about x-intercepts? What are the x-intercepts? There are none. So the answer is not 0. There just aren't any, right? There are none. Okay? What about the y-intercept? Does it cross the y-axis ever? No. So there's no x or y-intercepts here. Okay? What about the vertical asymptotes? Yeah, we already did that. occur at multiples of pi. Got it? Okay, last one. Last function, we got to do the secant. So everybody go to the secant. Put that one in your calculator. How am I going to put that one in my calculator? Yep, 1 over the cosine. 1 over the cosine of x. Okay, so, okay, where are the asymptotes? Let's decide that. Pi halves? Where else? 3 pi halves. Where else? Negative pi halves. Where else? Negative 3 pi halves. Where would we give a general description of where the asymptotes are? Odd multiples of pi halves. So it's going to be at pi halves, 3 pi halves, 5 pi halves, 7 pi halves, and so forth. Okay? Okay, what is the period? 2 pi, yep, just like the cosecant. It's just, this one goes from negative pi halves to 3 pi halves. It completes 2 of those things, right? That's a total of 2 pi. From negative pi halves to 3 pi halves is a distance of 2 pi. So it takes distance of 2 pi to complete a whole cycle, so that's the period. Okay, what's the domain? All number, the x numbers it can be. What x numbers can it be? All reals except odd multiples of pi halves. Yeah, all reals except for odd multiples of pi halves. Okay. What is the range? What's the range? Except for numbers between -1 and 1, right? Okay, good. Good. It can't be any of these numbers right through here, because this is kind of like a no man's land right here, in between here. There's no part of the graph that exists between -1 and 1. Huh? It is touching 1. So it doesn't include -1. I mean, the range includes -1 and +1. So it's just the numbers between them that doesn't include. Okay, next question. Where are the x-intercepts located? X-intercepts. There are none. It doesn't ever cross the x-axis. Okay? Y-intercepts. Okay, 0, 1 or 1. That's the only time it crosses that one. And where are the vertical asymptotes located? Okay, we already did that one. Yep. Okay. So let's review. What is the period of each of the functions? There's 6 functions. Oh wait, you know what? I forgot to show you guys something cool. This is cool about the sine and the cosine. I mean the cosecant and secant function. This is a secant, right? So 1 over the cosine. If you go graph the cosine in at the same time, look how the hills and valleys touch. They're tangent to each other. Kind of cool, huh? I've always thought that was cool, how they follow that pattern. Okay, the secant, yeah, the cosecant and the sine function do the same thing. It will do that forever in both directions. They'll touch each other. Okay? All right, so which functions have a period of pi and which functions have a period of 2 pi? Okay, tangent and cotangent have a period of pi. And then which ones have 2 pi? All the rest, how many are there? 4. Sine, cosine, secant, and cosecant, right? Okay, so that's that question. Next question. We're going to play guess the function. Okay? I am going to put, I want you, oh, don't put that window in. Use the window you've been using. The only difference is this one says y min is negative 5, y max is plus 5. I want you guys to go from negative 10 to positive 10. Okay? I'm going to put a function in. You guys have to guess what it is. Okay, so
You don't really see hypnotized you. Oh. I thought you just doing a card trick. We hypnotized you.
okay, what you're going to do, you guys, there's the function. I had Smarties, but my first period class, I gave them all out in there. I was giving them to the winners.
Wow.
But the first person to show me this, I'll get a prize for you next time. Now, I just want you to bring up your calculator and show me the graph and the equation once you get this. You can only win once. But, by the way, the next test, this is how the next test is going to be. You've got to figure out the equation. I'll give you a graph that looks like this, and you have to figure out the function that gives that. Okay? So, yeah, the answer is y equals tangent of 2x. And the answer to that is that the 2 just causes 2 cycles take place between 0 and 2 pi. 0 and pi, I mean. Okay, good job. We had several people get this one. The answer to it, if you haven't got it yet, is 1 over the tangent of 0.5x. What does the 0.5 do when you times it by x? Only half a cycle takes place between 0 and pi, right? So when you look at this graph right here, between 0 and pi, only half of one of those tangent functions took place. Okay? Okay, next one. Oh, man. No one even said anything to me. Okay, see if we can get this one. Okay, good job for those who got it. This is what, if you haven't got it yet, 1 over cosine of x minus pi force. What does the x minus pi force do?
Shifts it over.
Okay, the pi force minus pi force shifts it over.
That's a bathroom.
If you need to, hurry. Okay, does everybody have that one? Okay, so the pi force shifts it to the right pi force. Someone put in 1 over sine of x plus 5 pi force. They shifted it. They had a sign and they shifted to the left, and that works too. Okay, good job.
What is this?
We did that one already, sorry. Okay. Okay, there you go. Next one. Okay, let me see what you got. Remember the plus, where you have that plus 1? It has to be something like pi fourths or pi halves or something like that.
But it works.
It's one of those red angles up there between 0 and pi.
Oh, it's the same though?
Yeah. Oh, you are so close. You're just one number you got to change.
What is this, 3 or 5?
Huh?
3 or 5?
Look how many cycles there are between 0 and pi. How many cycles are there?
This one?
3. There. Now it's right. Why are you hurting?
There you go.
You good?
I got it first.
Yes.
That,
Ow!
yeah, that. I think you had it right. Show me again. You got it.
Why is this?
What else? Yep, you got it.
I'm a little off.
Let me see your y equals.
Oh, I thought you meant on the where I put. Yeah, I know that.
Wait. Just let me see what you had.
Wouldn't I just get rid of the 0.5? Just be 2.
And it's not minus 3 because, or 3x or whatever. Oh. You switch the pi and the thing. You switch. Usually x comes first.
Oh, so it's
Close
3x?
Yeah, it's 3x. Minus what? Well, minus, it's got to be something, one of those angles in red. Pi 6, pi 4, pi thirds, one of those. Pi halves. Hey, by the way, you guys, like on this one, you can use a secant or a cosecant, right? 1 over the sine or 1 over the cosine. Okay, this is what I had. 1 over the cosine of 3x minus pi 6. Huh? Oh, sorry. That's what I had. 1 over the cosine of 3x minus pi 6. So the 3 made it so there's 3 cycles between 0 and 2 pi. And the negative pi 6 shifted to the right pi 6 units. We have that?